Alright, good morning. I'm doing something a little bit different today. I'm going to be recording my second video while my students are making my first video, so you can probably see some of them behind me. Just ignore them, focus on me. And for the rest of you guys in here, ignore me, focus on your video. Cool? Perfect. Alright, so we've been talking about scientific notation, and the key here is remembering that scientific notation is a tool to make us use numbers and make them more easy to write. So if I have a giant number like 300 million, instead of writing that out every single time, I can rewrite that in scientific notation. That makes it much easier for me. So I can write that again, remember, using just one whole number and using the rest of my digits and multiplying it by 10 to that power. So I can write it by 3. I can just write 3 if I want, times 10 to the, let's see how many decimal points I moved it over. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 10 to the 8th. And by writing this, remember, it's much easier than writing it with the full number like that. Let me make sure I have it all lined up. Cool, perfect. So we've been talking about how to make them. We've been talking about how to convert them back and forth. And last section we talked about comparing them and figuring out which scientifically notated number is larger than the other one, right? Today we're going to be talking about how to add, subtract, multiply, and divide them. In short, how to add, subtract, multiply, and still good, and divide. So we're going to start with the easier two first. Of course, they're always addition and subtraction. So how to add and subtract. Those are going to be our key things. Now, our first, in order to do this, we have 3 steps to follow. So let's write the steps out. Then we're going to do a couple of examples. Then we're going to do the multiplication and the division the same way. So let me move my paper up so that you guys can see, and let's write our rules. Our first rule, our first step that we would do, is we are going to rewrite the smaller number, which is the number with the smaller exponent, so that it has the same exponent as the other number. So rewrite the smaller number so it has the same exponent as the larger number. And just like when we were comparing, this is going to help us make sure that we line up our place value and the values of all the numbers that we're using. Because just like always, our place value is incredibly important when we're looking at these numbers. The second thing we're going to do is add or subtract the decimal numbers. The powers of 10 don't change. They stay the same. We're only looking at the decimals because when I have a big number and I'm subtracting them, I don't look at the zeros. I just ignore them. So we're going to do the same thing. We're going to pretend like they're zeros. And then I may need to reconvert to scientific notation. Scientific notation, if I need to. Let's see how it goes. Okay, let's take a look at a couple of examples. Okay, first, I think I have enough space on this page to do one, so I'm going to do that one right here. I'll make sure that it fits. Cool. All right. We are going to do 5.7 times 10 to the, that is small, it's 10 to the 4th, plus 4.87 times 10 to the 5th. Okay, so let's go through our steps. Let's first mark this as example 1 so we don't get confused. Example 1, not just example. Okay, number 1 says rewrite the smaller number so it has the same exponent as the larger number. Okay, so if I look at these two numbers, I'm going to need to use my comparison to figure out which one's smaller. And the way that I do that, remember, is I first look at the powers of 10. And I know that 10 to the 4th power is less than 10 to the 5th, so this is my smaller number. I need to turn it into a times 10 to the 5th. So to do that, I'm going to turn this into instead 0.57 times 10 to the 5th, which I can do because I'm really just moving the decimal point 1 over, and now it is 10 to the 5th. Now, it's no longer in scientific notation, but that's okay because I don't need it to be scientific notation right now. I reconvert at the end when I get my answer. So now I have 0.57 plus 4.87 times 10 to the 5th. Now I can ignore my exponents right here and just look at the decimals. So I have 0.57 plus 4.87. And now, again, we're going to need to remember all those rules that we've been talking about. Here again, notice that I made sure to line up my decimal points because I'm going to bring that decimal point right down. Oops, let's make it a little bigger so we can see it. And that's important for when we're adding or subtracting decimals. Okay, let's do our little math. 7 and 7 is 14. 5 and 8 is 13. Plus 1 is 14. And I have 5. So I have 5.44 times 10 to the 5th, because my exponents stay the same. So that's how I would do this. Now I can check, is this in scientific notation? It is, because I only have one whole number outside of my decimal, so I'm good to go. Everything works. Okay, let's do another example with our addition and subtraction. Okay, example 2. All right. This time, let's take a look at this problem. Okay, let me find one that I like. Alright, we're going to do 7.14 times 10 to the 4th minus 5.5 times 10 to the 3rd. Okay, so again, my first step is I need to make sure that my numbers are both have the same number of exponents after them. So I'm going to find my smaller one. I'm going to look at 10 to the 4th and 10 to the 3rd. Okay, this is definitely my smaller one because 10 to the 3rd is less. Because 10 to the 3rd, remember, is 1 with a 1, 2, 3 zeros, which is 1,000. And 10 to the 4th, which is 1 with 1, 2, 3, 4 zeros, which is, which is 10,000. And 10,000 is definitely bigger than 1,000. So I need to turn this one into a similar amount of exponents in that times 10 part. So I'm going to move the decimal point one place to the left, because whenever I move it to the left, it gets bigger. Whenever I move it to the right, it gets small. So I'm going to do 0.55 times 10 to the 4th. So now I have 7.14 times 10 to the 4th minus 0.55. And then I can just set it up like normal, and I'm pretty much good to go. 7.14 minus 0.55. Again, my decimal points, very important to line up. 4 minus 5, can't do that, I'll have to carry. 14 minus 5 is 9. Well, 0 minus 5, can't do that either, I'll have to carry. So now I have 10 minus 5 is 5, 6 minus 0 is 6. So I have 6.59. And I need to bring my same exponent that I used. So I'm going to bring down times 10 to the 4th. And now I'm good to go. I've got my answer, and just like I forgot to do last page, oops, I'm going to make sure to box it up so that I know which answer is correct. Okay? Addition and subtraction are pretty easy. Well, they're easy compared to multiplication and division of these numbers. So you are, it pretty much kind of goes like this. I think we're good. So let's take a look at multiplication and division. Rules for multiplication and division. Okay, so when I'm adding and subtracting large numbers, those zeros don't matter at all. So I can really ignore them as long as I make sure they line up correctly. So the reason that I always have to line things up when I'm doing addition and subtraction is because place value is incredibly important in those operations. But in multiplication and division, place value isn't as important because 1,000,000 divided by 4 and 100 divided by 4, both are going to change their place values. Okay? So here's kind of how it goes. We're going to write out our rules, and then we are going to do some examples just like we did with addition and subtraction. Okay, our rules go like this. First, we're going to multiply or divide the decimal numbers. Then multiply / divide the exponents. And for this one, we're going to have to remember that to multiply or divide exponents, we add or subtract them. So remember, it's adding and subtracting. And for number 3, our last step is we may need to reconvert to scientific notation. All right, let's take a look at a couple of examples because this one's a little bit different. So one of the big keys, though, to notice is that our first step is not like it was before, where we have to rewrite the smaller number so that it's the same, because it doesn't matter. Remember, place value doesn't need to be preserved in the operation when we're doing division and multiplication. They only have to be preserved within it. Okay, so let's take a look at an example before I confuse you even more. Let's look at this one. We have 1.2 times, where'd it go? 1.2 times 10 to the 4th times 3.4 times 10 to the 4th. All right, so here's what we're going to do. We're going to follow our steps. Let's label this example 3. So my first step is I divide the decimal numbers. So I'm going to multiply, because this is my little multiplication, 1.2 times 3.4. Okay, you can do it on a calculator if you want. I'm just going to do it quick here. 1.2, 3.4, 8. 4 times 4 is 4. Sorry, 4 times 1 is 4. Then 3 times 2 is 6. 3 times 1 is 3. 8. 4 plus 6 is 10. And 4. So then I have 2 decimal points. I have 4.08. So I have 4.08 for my whole number. Then I have to multiply my exponents. So if you recall when we were talking about multiplying exponents, it's different. We can't just say 4 times 4 is 16. So if I have 10 to the 4th times 10 to the 4th, it does not equal 10 to the 16th. We don't just multiply it. We don't do that. Instead, when we multiply exponents, you'll recall that we need to add them together. So instead, 10 to the 4th times 10 to the 4th is equal to 10 to the 4 plus 4, which is equal to 10 to the 8th. And that's how our multiplication of exponents works. Whenever we are multiplying them, we add, and whenever we are dividing them, we subtract. Okay, so my answer is going to be 4.08 times 10 to the 8th. So it got much larger. I went from 10 to the 4th to 10 to the 8th. I got many, many more zeros because that's how multiplication works. Okay, let's look at another quick example. Example 4. All right. Let's do, we're going to take a look and go 7.3 times 10 to the 7th times 6.2 times 10 to the 4th. Okay, so my first step again, just like it was before, I'm going to do 7.3 times 6.2. So I'm going to do that over here. 7.3 times 6.2. 2 times 3 is 6. 2 times 7 is 14. Put a 0, cross it out. 6 times 3 is 18. 6 times 7 is 42. 43. 6, 4, and 8 is 12. 1, 1, and 3 is 5, and a 4. So I have 4,526, but I need to count my decimals, 1, 2. So I really have 45.26. Okay, so that's what I have for my whole number. And now I have to look at my exponents. I have 10 to the 7th times 10 to the 4th. And if you recall from before, what I do is I add them. So I can write 10 to the 7. Oops. I meant 10 to the 7 plus 4. And 7 and 4 is 11, so that gives me 10 to the 11th power. So I can write my answer as 45.26 times 10 to the 11th. I have a problem. This is not scientific notation. Because notice I have more than one whole number after my decimal. So I'm going to use the very bit of my paper. Oops, I've been off my paper for a while. I'm so sorry. And I'm going to use the last bit to my paper to remind us how to make this into scientific notation. I am going to move the decimal point one place over. And whenever I move it to the left like that, that means I add one more to the exponent here. So I can write it as 4.526 times 10 to the 12th. And now I'm correct because this is scientific notation. Okay, let's do a couple more. If you feel like you get it, this multiplication division, actually I want you to do one division before I send you off. So let's do a quick little division example, and then you can get started on your own. Alright, let's take a look at this one. We've got 24.6 times 10 to the 5th. Divided by, oops, I lost it, 6 times 10 to the 3rd. Alright, so again our steps. Where'd I put all my steps? I lost them. We're going to multiply, divide the decimal numbers. Then we're going to do the same thing with the exponents, remembering that I'll need to add or divide. Okay, so first I have 24.6 times 6. Let's do that. 24.6 times 6. 6 and 6 is 36. 6 times 4 is 24, plus 3 is 27. 6 times 2 is 12, plus 2 is 14. I have one decimal point. I'm going to stick it right in here. So I have 147.6. Okay. Now I need to do my exponents. I have 10 to the 5th divided by 10 to the 3rd. And remember, I can rewrite that as a subtraction. So I can say it's 10 to the 5 minus 3 power, which is really 10 to the 5 minus 3 is 2. 10 to the 2nd. So I can write this as 147.6 times 10 to the 2nd. But, same as before, This is not scientific notation. So I need to take it and go a little bit farther. And I'm going to go 147. I'm just going to rewrite it below because I kind of used that spot. 0.6 times 10 to the second power. So I need to move this decimal point 2 places over. And whenever I move it to the left, 1.47 like this, I need to add to the exponent based on the number of squares that I move it. So I can write this as times 10 to the 4th. Nice. There we go. All right. That's pretty much how we're going to do it. If you feel like you got it, go ahead and go on. I'm going to do one more, and I'm going to use my negative exponents this time. And just remember, when you're doing negative exponents, it's the same as adding and subtracting negative numbers. So it's different and kind of tricky to remember using that number line than we've been using before. So let's take a look at one more if you are still staying with me. Okay. Let's do example 6. 6.4 times 10 to the negative 4th times 7.4 times 10 to the 3rd. Okay, so this time I'm doing a very small number times a very large number. So again, I'm going to do what I did before. I'm going to do my whole numbers first. 6.4 times 7.4. Let's see, 4 times 4 is 16, 6 times 4 is 24, 25. Put my 0 in 7 times 4 is 28. 7 times 6 is 42, plus 2 is 44. 6, 13, 4 and 2 and 5 is 7, and 4. I've got 2 decimal points. I have 47.36. Now I have my exponents. I have 10 to the negative 4th times 10 to the 3rd. Oops. Let me rewrite that, sorry. 10 to the negative 4th times 10 to the 3rd. Okay, so we are adding these, but I'm going to have a negative number in here, because remember, whenever I multiply, I add them. So I can say this is 10 negative 4 plus 3. Negative 4 plus 3, that's kind of remembering back to our number line. And I can count this way up 3, negative 4, so I'm really at negative 1. So I have 10 to the negative 1. So this is times 10 to the negative 1 is how this works, because that equals 10, oops, I'm probably in the wrong spot, to the negative 4 plus 3 equals 10 to the negative 1. Now again, I'm going to have to fix this up by moving this 1 over to this direction. Whenever I move it left, I add 1. So I really have 4.736. And in this weird example, my times 10 just turns into a times 10. Kind of makes sense? All right, good luck.